Let's learn about string data type in detail. Strings are sequence of characters in Python. They are an instance of string class. Strings are immutable sequence of Unicode characters. This means they can include characters from different languages across the globe. If you don't know about Unicode characters or character sets, don't worry about it. It simply means that it can accommodate different kinds of strings. Strings can be created using single quotes, double quotes, or triple quotes. If we want to write multi-line string, then triple quotes provide a convenient method to create them. We have already seen the string concatenation operation. We can use the plus sign to concatenate two strings. This simply means it will join two strings together. Here I have this hello string and I'm concatenating that with John. As an output, it returns hello John. If I multiply a string by any number, then it will return that string that many number of times. If I multiply, let's say hello, with 3, then it returns hello string joined together 3 times. As I mentioned earlier that strings are sequence of characters, that means they are indexable. Every character in the string have some kind of index on them. Let's understand a little bit more on the whiteboard. Let's suppose I have this hello string, then each character of this string have index starting from 0. In Python, indices start from 0. So our first character H has the index position 0. Second character E has the index position 1. And the last character has the index position 4. In Python, unlike other programming languages, we can also index strings from the right hand side. We can use the negative indices if we want to start from the right hand side. So the last character is at index position -1. We can use these indices to get that specific character. Let's understand this in code. Let's say I have this string, hello there. Now if I want to get the second character, I can use this variable name and then I can write any index position in the square brackets. Indexing operation uses this square bracket notation. So if I check string 1, it returns the second character of the string, which is at index position 1. If I check the fourth index position, then it returns O. If I want to check the index position from the right hand side, let's say -1, then it returns the last character of this string. As I mentioned, strings are immutable. That means we cannot modify a part of the string by using these indexing operations. Our original string is hello there. Now let's say I want to modify this O character with A. I can try changing that like this. But if I run this, you can see that it throws type error. String object does not support item assignment. This simply means that string objects are immutable and cannot be modified. Similarly, if I try to look for an index that doesn't exist in the original string, then it throws index error. Here our string has index positions from 0 to 10. If I try to index an item beyond that index position, then it will throw index error. It says string index out of range. We have seen the use of len function to check the length of the string. I can make use of that len function in order to avoid this kind of index errors. Let's say I have a string hello, then I can check its length using len function. It returns 5. So the last character of any string will have the index position equal to length of the string minus 1. If I check that using this len function, then it correctly returns last character. So now we are sure that index positions can be from 0 to the length of the string minus 1. In Python we also have string slicing. This means if we want to get a substring from the original string, we can use this string slicing operations. We can use our knowledge of indexing operations for this string slicing. String slicing also uses the square bracket notation. In that we will specify the start index and the stop index. All the elements between these two indices will be available in the output. Let's check out a practical example. If I have a string with value hello there, if I want to get only these two L characters, then I can get that using string slicing. The first L character is at index position 2. So for slicing operation, I have to specify the start position as 2. And I want to go up to this O character, which is at index position 4. The stop position is not included in the output, and it returns 2 L characters. It returns the characters from index position 2 and 3, but the item from the 4th index position is not included in the output. Similarly, if I want to get this substring hello, then I can use string positions 0 and 5. To get this last 5 characters, I can use string 6, 11. The interesting part of this slicing operation is that we can go even beyond the length of the string. So if I try to index from 6 to 15, then it returns all the characters starting from index position 6. In this case, it only has these 5 characters and it returns those. Unlike indexing operation, this operation doesn't throw any error when we try to slice up to the index position 15. Now there are also few tricks to simplify these slicing operations. Our original string has the value hello there. Now if I write string 0 colon, then it returns complete string. By default, when we don't specify the stop position, it will go up to the end of the string. That's why it returns all the elements from index position 0 up to the length of the string. If I want to get the last 5 characters, then I can write string 6 colon. I don't have to write the stop position. It will by default go up to the length of the string. And you can see that it returns last 5 characters. Similarly, if I don't specify the start position, it will by default start from the beginning of the string. So string colon 5 will return the first 5 characters of this string. It returns hello. In slicing operations, we can also specify the third item, step. Let's take a practical example first. If I have a string variable with value hello, and if I write string starting from 0 index up to index position 5 with a step value of 2. If I run this, it returns every other character starting from index position 0. So it returns a substring with index position 0 index position 2 and index position 4. That's what this step option does. If I have a variable with value 1, 2, 3, 4, 5, 6, 7, 8, and now if I want to get every other element from this number string, let's say I want all the odd numbers, then I can write string 0 colon. I don't have to specify the stop index because it will by default go up to the end of the string. And if I specify the step position as 2, then it returns the output of 1, 3, 5, 7. Similarly, if I want to step through every third item, then I can simply specify the step position as 3. And this will return 1, 4, 7. To make it easy to work with string data types, Python itself provides some methods on them. Methods are similar to functions. The main difference is that methods are invoked using dot notation. We were able to invoke a function using function name and we were passing some parameters. While invoking methods, we have to specify the object name, dot, method name, and we can pass the parameters like functions. We have already seen few examples of this. We have seen the format method. Let's take a look at that again. We have a format method which is used to format a string. I can write print hello. In the curly brace, I specify the index position 0. After that, I can write dot format. This is how you invoke every method using dot and then the method name. This method takes arguments. If I specify John, then this value John will replace this 0 index position. If I run this, you can see that it prints hello John. I could also use keyword arguments for this. If I replace this 0 index position with variable name, and in the format method, if I pass this keyword argument name equals John, then it will print the same output. We can find all the available attributes and methods of an object using built-in function dir. If I have a string with value hello there, and if I call dir function on this string variable, you can see that it returns all the available attributes and methods on this string data type. All these items with double underscores are special methods or attributes of this string object. But we also have these methods. We have already seen this format method, and we will explore some of these methods in this video. If I want to convert our string into lowercase, then I can use the lower method. If I write string.lower, then it converts our original string into lowercase. Similarly, if I want to convert our string into uppercase, I can use the upper method. If I want to swap the case for each character of the string, then there is a method for that, swap case. You can see that it has changed the case for every character of the string. If I want to make our string title case, that means every word will have the first character as the uppercase and every other character as lowercase. Then I can use title method for that. Similarly, there is a method to capitalize our string. String.capitalize, and it returns the same string. So what exactly does it do? We can check the information about a method using help function. Help string.capitalize, and it returns a simple documentation on this method. It returns a capitalized version of the string. More specifically, make the first character have the uppercase and the rest lowercase. So that makes sense because our original string had first character as the uppercase. It seems that it did not do anything. But let's modify our original string variable. This time I'm creating string with all lowercase characters as hello there. Now if I run string.capitalize, then you can see that it converts the first character into uppercase. If I have a string with white space around it, then I can use else strip function to remove all the white space from the left hand side. Here I have this string hello there with white space on both the sides, and if I invoke else strip method on this, it returns this string where the left hand side white space has been removed but right hand side white space is still there. Similarly, I can use rstrip method and it will remove the white space from the right hand side. There is also strip method which will remove the white space from both the sides. There are methods to check whether our string contains all the alphabetic characters or numeric characters and so on. These methods usually start with is. All these methods are yes/no kind of questions. Whether our string contains all the alphabetic characters, the answer is going to be yes or no. Whenever a method starts with is, you can guess it that this method is going to return Boolean data type. So if I check hello.isAlpha, this is used to verify if the string contains only alphabetic characters, then it returns true. If I modify this string and write hello1, now it has this numeric character 1, and if I run this, it returns false. Similarly, there is a method isNumeric to verify if the string is completely numeric. For example, 123 dot is numeric and it returns true. We can also verify if our original string starts with another substring. So hello there dot starts with hello. It checks whether our original string starts with this substring. In this case, it starts with that substring, so it returns true. Similarly, we can test whether our string ends with specific characters. In this case, it returns false. We can also split our string based on some specific character. So if I write this is simple text dot split, then it will split our string into individual words. The split method by default splits at white space. So it returned a list with all the words in this string. If I want to split based on some specific character, then I can pass that character in this split method. If I have a comma separated string, if I pass comma into this split method, then it will split the original string wherever there is comma. Here you can see that it returns a new list with all the words. We have not seen these list data types, but we will learn about them in the next video. Similarly, if I have a list of words, then I can join those words together based on some delimiter. If I write space dot join, and this join method takes the list. I pass this list into this join method and it returns a string joined together with this character. If I write -.join list, then it returns this new list with all the elements joined together using this hyphen character. If I want to find an index position of a specific character or specific substring, then I can use index method for that. If I have a variable with value hello there, then if I want to search for the index position of this substring there, I can use the index method. It returns 6. This is the index position where this substring starts. Similarly, if I want to search for an index of single character, then I can pass that character into this index method. This by default returns the first occurrence of this character. If I want to find any other occurrence after this index position, then I can pass the second argument into this method. If I check this character E starting from index position 2, then it returns 8. This is the index position for this character E. I can also search a string from the right hand side using R-index. If I search for character E from the right hand side, it returns 10. This is the last index of this string hello there. If I try to look for a substring that doesn't exist in the original string, then in that case it returns value error. If I try to look for hi in my original string, then you can see that it throws a value error, substring not found. There is another method to find out if a substring exists in the original string. We can use find method. So string.find there, and it returns the same index position 6. But the advantage of this find method is that if I try to look for a substring that doesn't exist in the original string, it doesn't throw any error. It simply returns -1 for those kind of cases. We could also replace original substring with some other substring. We can use the replace method for that. Our original string is hello there. If I write string.replace hello with hi, the first argument is the substring that we want to replace, and the second argument is the substring we want to replace with. If I execute this code cell, it returns hi there. As I mentioned, strings are immutable. Then how does this operation work? This replace method simply returns a new string. If I check my original string, it still has the value hello there. We could verify this by using the id function we saw earlier. Id function returns the memory location where this object is saved. So if I check id of our string object, then it returns this memory location. If I check the id of string.replace hello with hi, then it returns a new memory location. That means these two strings are saved in different memory location and they are totally different objects. So in this video we covered a lot of material on string data types. Strings are very important data type because you will always come across this kind of data in your data analytics or data science jobs. So understanding string data types and their methods is very important.